Let's see. All right, two caves each contain both petrifying pink pigs and barbaric baby bunnies. Cave A has 6 pigs and 4 bunnies, while Cave B has 2 pigs and 6 bunnies. 6-sided die is used to select a cave. 1 or 2 means Cave A, 3, 4, 5, or 6 means Cave B. One animal is removed at random from the selected cave. Find the probability that the animal animal was a bunny taken from Cave B. Okay, so what is the probability that it was a bunny that was taken from Cave B? Let's see if we can figure this. So we made a tree diagram here to figure out, to just try to help us make this a little bit easier. Okay, so the first thing we're going to do is we're going to choose a cave, right? So it's going to be either Cave A or Cave B. So 1 or 2 is a Cave A, so that is 2 of the 6 possibilities. And then 3, 4, 5, or 6, the other 4 out of the 6 possibilities would be Cave B. Okay? Now, in Cave A, the animal has got 6 pigs and 4 bunnies. So if we are looking at, like, say, drawing a pig and then the bunny, pig, and then bunny. So the probability of getting a pig out of Cave A is 6 out of 10, where that means the other 4 out of 10 would have to be bunnies. And then if it's Cave B, there's 2 pigs and 6 bunnies, so that's 2 of the 8 total animals are pigs, and then 6 out of the 8 total animals are bunnies. Okay? Once we have this all filled out, it makes these questions a lot easier. What's the probability that it was a bunny taken from Cave B? So Cave B and then bunny. That's this set of branches here. So that's 4, 6 times 6, 8, right? Those 6's can reduce. That 4 and 8 can both be divided by 4. So that just ends up being 1/2, 50% chance that it was a bunny taken from Cave B. Okay, what's the probability that it was a pig? So if it was a pig, that could be either this branch or this branch here. So we'd have to figure out both of these and add them together, right? So that's going to be 2, 6 times 6 tenths plus 4 6 times 2 eighths. Let's simplify this as much as we can. The 6's go away. That turns into 1/5. And then let's see. 4 and the 8 turn into a 1 and a 2. 6 and the 2 is a 3 and a 1. So this is, those are both 1. So that's going to be 1/5 plus 1/3 times 2 is 1/6. Okay, so you can go through and get common denominator, or we can just do this. 1/5 plus 1. That's not what I wanted to do. 1/5. Move the arrow over. Plus 1/6. And there we go. And that gives us 11/30. 11/30 chance that it was a pig. Okay. One last quick example. I know we're running along here, but let's just do one last quick example. Example 20, Sheila walks into a lighting store. Of the 12 customers in the store, 5 like lamp A the best, 7 like lamp B the best. 3 customers are selected at random to determine the probability that this happens. So let's go through. Again, I'm going to make a little tree diagram to make this easier. Okay, so here's what our tree diagram could be like. Customer 1, customer 2, customer 3. So they're gonna select 3 customers. So what you want to do is think of this as selecting one customer, then another customer, and then another customer. So first customer is, let's see, that likes lamp A. Let's see, 12 of the customers. 5 said they like A, and then 7 said they like B. So this would be 5 out of 12, and this would be the other 7 out of 12, right? Now, one customer has already been chosen. So if one customer liked lamp A best and they were chosen, that means there's only 4 left for A up here, right? So there's only 4 of these guys left, and there's still 7 of these guys left. Whereas if they chose B first, there's still 5 left that like A best, and there's only now 6 left left that like B the best. So if we were to get A again, that would be 4 out of the 11 that are left, where this would be 7 out of 11, and this would be 5 out of the 11, whereas this is the 6 out of 11. Okay, so now, so this is a person here, a second person is now out, so now we're down to 10, right? So we have, if we've taken an A and an A out, if we took an A away from the 1 away from the 4 A people, that means there's only 3 left. We still haven't taken any away from the B over here, so that's 7. On this one here, we had 7 B's. If we took a B away, that would leave 6 left, so that means there's got to be 4 left for A. If we had an A here, and there was only 5 of those, we take 1 away, that's 4 left there. That means there's got to be 6 left for B. And if we took a B away here, that means there's 5 left for B, and there's 5 left for A. So then now we can figure out this last one here. So this here, there's going to be 3 out of the 10. This is 7 out of 10. 4 out of 10. 6 out of 10. That's a 4. Sorry, that's hard to read. This is 4 out of 10. 6 out of 10. And this is 5 out of 10 and 5 out of 10. Okay, so once you make all that, that makes this a bit easier. All 3 customers liked A the best. So that would be A. That's this branch right here. So that's going to be 5/12 times 4/11 times 3/10, which simplifies down to 1 out of 22. Okay, exactly 1 liked B the best. Okay, so that means, let's see, that would be AAB. So that would be, let's do this a different color. So here's 1 that likes B the best. This is an ABA. There's 1 that likes B the best. That's 2 B's. That's 1 B and 2 A. So that's exactly 1. That is 2 B's. That's 2 B's, and that's all 3 B's. So it's going to be these 3. So it's going to have to be these all multiplied together, added up. Okay. So here's what these all are multiplied together. So that's these 3 gives us 766. These 3 all give us 766, and these 3 also give us 7/66. So we have to add those all together. So basically we have 3 766, which ends up reducing down to 7/22. Okay. Last one. At least 1 liked B the best. So that would be all of these. Only one that it wouldn't be, it would just not be this one right here. Okay. So easier than going through and finding all 7 of those and adding them all together is we can just take 100% and then subtract the 1/22. So basically this is going to be 1 minus 1/22. So really that would be 22/22 minus 1/22, which means that's going to be 21 out of 22. It's going to, at least one of them liked B the best. There's a 21 out of 22 chance. Okay? All right. Sorry, that was a little bit long. If you have any questions on this at all, please feel free to ask in class.